Welcome back, calculus. All right, in pre-calculus, we talked about how we could find out whether we had a horizontal asymptote, whether the asymptote didn't exist, or whether we had a slant asymptote. And so we're going to go back and look through some examples of those, and we're going to talk about ways that we can find the limits of these guys. And by limits, I mean infinite limits of these guys. So before we found limits, say, at the asymptote of this guy, but to find the end behavior limit, so the limit as x goes to infinity or negative infinity, we're going to explore this here. So first thing we're going to do is we're going to take this function here and we're going to divide it by the highest degree in the denominator. We're going to divide every term in this function by the highest degree in the denominator. So the limit as x goes to infinity, so this would be x over x squared plus 2 over x squared over x squared over x squared plus 5x over x squared plus 6 over x squared. And I know this looks really funky, but once you've done a couple of these, it's going to come really fast to you. So again, what we did is we took every term in the function and we divided it by the highest power of x that's in the denominator. So the highest power here is x squared. I took each of these terms and divided it by x squared. All right, and when I do that, I'm going to do some cancellation. So as x goes to infinity, this would be one of these x's cancels out. So this is really just 1 over x. This is 2 over x squared. Nothing cancels there. There we go. And then x squared over x squared would be 1, and this would be 5 over x, and then 6 over x squared. And you may be going, well, how did that help us any? Well, here's the thing. What happens as x goes to infinity here? If I have 1 over, say, 100, that's going to be really close to what value? 0, right? What about 1 over 1,000? It's going to be even closer to 0. Well, as x gets super, 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 super big in the denominator, this guy is going to go to 0. So the limit as x goes to infinity of just this piece here is 0. So this is going to be 0. Something over x squared is going to get to 0 even faster because x squared is going to get even bigger faster. And then I've got 1, and this is going to go to 0, this is going to go to 0. So I end up with 0 over 1, which is 0. Well, guess what? Let's look at that graph. What's happening as x goes to positive infinity? We're getting close to that asymptote, which is at 0. And so we know from pre-calculus, tells us that if the degree of the denominator is bigger than the degree of the numerator, then a horizontal asymptote exists, and that's at y equals 0, this guy here. All right, you agree with all that? All right, let's do it again. This time we're going to do it with a different function. We still have the same denominator, but this time we've got something different happening in our numerator. Notice this time, though, what's the degree of our denominator? 2. What's the degree of the numerator? 2. So are we going to have a horizontal asymptote there? No, that's only when the denominator is bigger than the numerator. Do you guys remember? Because we just did it in the last one. Where should our horizontal asymptote be for this one? If the degree of the numerator and denominator are the same, what did pre-calculus tell us? The degree of the denominator equals the numerator. The horizontal asymptote is at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So in this case, 2 over 1, which is at 2. So I think this should go to 2, but we're going to do a little bit of calculus to make sure that that actually is the case. So let's go ahead and do what we said before. What was our process? We took each term and divided it by the highest degree in the denominator. Not in the numerator, but in the denominator. So I've got 2x squared over x squared plus 7x over x squared plus 6 over x squared. In the denominator, I've got x squared over x squared plus 5x over x squared plus 6 over x squared. All right, simplifying each of those pieces as x goes to infinity. The x squareds cancel here, and so I've got 2 plus 1x cancels with one of these, so that's 7 over x. Nothing to cancel here, so 6 over x squared. X squared over x squared is 1, plus 5 over x, plus 6 over x squared. All right? If I were to put infinity in for each of these x's, these numbers on the bottom would be really big, which means my fraction is incredibly small. I'm getting close to 0. So this is 2 plus 0 plus 0, all over 1 plus 0 plus 0. And so that gives me 2. And that's what we thought it would be, right? As we go to negative infinity, or in this case going to positive infinity, we're getting close to that horizontal asymptote, which we know from pre-calculus is at 2. All right? And what's different about our last case here? From pre-calculus, what did we know? If the degree of the denominator is less than the numerator, what kind of asymptote do we have? A slant asymptote. And do you guys remember how we found that? We did some division. We divided the numerator by the denominator, and the resulting polynomial, your remainder polynomial, is the equation for your slant asymptote. All right? But let's go ahead and do our calculus route. Again, be careful. It's not the highest degree of the numerator, it's the highest degree of the denominator. So this time, instead of dividing by x squared, we're dividing by what is in the highest degree of the denominator. So this time, we're only dividing by x. So I've got x squared over x plus 3x over x plus 2. On the bottom, I've got plus 2 over x. On the bottom, I've got x over x minus 1 over x. All right? Simplifying that would be the limit as x goes to infinity. X squared over x is x. 3x over x is just 3. And then plus 2 over x. At the bottom, I've got 1 minus 1 over x. Now, as we plug in infinity, what do we have going on here? This guy here would go to 0. So I've got infinity plus 3 plus 0 over 1 minus 0. All right? So if I say infinity plus 3, how big is that? It's infinity, right? There's no such thing as infinity plus 3, because that's the concept that keeps going on and on. As long as we're over 1, if we're infinity over infinity, we're going to have trouble. But if we're over 1, this guy is just going to be infinity. And so that's what's happening here with our slant asymptote as y goes to infinity. This guy's going off to positive infinity. All right, that's it. We're going to come back, and in the next video, we're going to take a quick look at what happens when we go to negative infinity, and we're going to keep going.